Betelgeuse, one of the most iconic stars in the night sky, has long fascinated both professional astronomers and amateur stargazers alike. With its distinctive reddish hue and sheer size, this star stands as a majestic beacon in the constellation Orion, clearly visible to the naked eye from Earth. But recently, Betelgeuse has been thrust into the scientific spotlight for a far more compelling reason: a stunning and sudden 250% increase in brightness as observed by the James Webb Space Telescope. This unexpected phenomenon has ignited fresh excitement within the astronomical community and sparked a new wave of questions about the star's current behavior and its future destiny. Classified as a red supergiant, Betelgeuse is in the final stages of its stellar life cycle. Positioned roughly 642 light-years from Earth, it ranks among the largest and brightest stars in the Milky Way galaxy. Boasting a radius nearly 700 times that of the Sun and shining with a luminosity over 10,000 times greater, red supergiants are inherently unstable as they near the end of their lives, known for erratic cycles of dimming and brightening. Yet, even by these volatile standards, Betelgeuse's most recent surge in brightness is wholly unprecedented, marking a major event in the field of stellar astrophysics. Thanks to its cutting-edge infrared capabilities, the James Webb Space Telescope, JWST, was instrumental in detecting this dramatic change by penetrating the dense clouds of dust and gas that enshroud Betelgeuse. The JWST provided a clearer and deeper view of the star's surface and surrounding environment. What the telescope captured stunned scientists. The star's brightness had spiked by an astonishing 250% in just a matter of weeks. Such a rapid and significant transformation suggested that a powerful and unusual process was unfolding within the star. This development holds significant implications. For decades, astronomers have speculated that Betelgeuse might go supernova, a cataclysmic explosion that signals the death of a massive star once it exhausts its nuclear fuel. While this event was originally projected to occur within the next 100,000 years, the latest energy surge has fueled speculation that Betelgeuse might be edging closer to that finale much sooner than anticipated. The erratic behavior displayed by the star in recent years, capped by this explosive brightening, points to an increasingly unstable phase that may precede a supernova event. If Betelgeuse were to explode, the spectacle would be unparalleled in human history. The supernova would be so luminous that it could be seen during daylight hours and would likely outshine the full moon for weeks. Despite the magnitude of such an event, Betelgeuse's distance from Earth is sufficient to ensure that it poses no threat to life on our planet. Instead, it would offer a once-in-a-lifetime scientific opportunity, a real-time observation of a nearby supernova, providing a treasure trove of data and insight into the complex mechanics of stellar death. This newfound brightness also reinvigorates ongoing inquiries into the inner workings of red supergiants. These massive stars defy easy classification due to their colossal size and turbulent interiors, which generate complex and unpredictable dynamics. Betelgeuse in particular has long baffled scientists with its irregular light variations. Determining the cause behind this dramatic 250% increase in brightness may unlock critical knowledge about the life cycles of red supergiants and the physical processes driving their instability. One emerging hypothesis is that Betelgeuse underwent a massive convective event, a giant bubble of hot gas rising from the star's core to its outer layers. Such convective cells are not uncommon in stars of this type and can result in substantial luminosity changes, particularly when material is violently ejected from the star's surface. This outflow of hot gas into space could explain the observed brightness spike, as the newly exposed and energized regions of the star shine more intensely. Another possibility is that the star recently experienced a stellar eruption, shedding a substantial amount of mass that formed a cloud of dust and gas. This material, now illuminated by the star's intense radiation, could be contributing to the increased brightness. This theory also aligns with the 2019 dimming event, when Betelgeuse mysteriously lost much of its visibility, an episode many scientists now attribute to a dust cloud partially obscuring the star. The current brightening may in fact be a rebound from that previous obscuration, caused by newly ejected matter reflecting and enhancing the star's natural light. A third intriguing theory involves Betelgeuse's magnetic field, a component of the star's nature that remains poorly understood. Some studies suggest that red supergiants may possess highly complex and dynamic magnetic fields that could directly influence how energy travels through the star's layers. Changes in this magnetic structure might trigger sudden shifts in brightness, and the recent luminosity spike could be a manifestation of such magnetic upheaval. If this is the case, it not only expands our understanding of Betelgeuse, but opens up a broader avenue of research into the magnetic behavior of massive stars, an area that has long eluded detailed exploration. While scientists diligently observe Betelgeuse, the star's evolving brightness also shines a spotlight on the critical role that stellar mass loss plays in the late stages of a red supergiant's life. These stars are notorious for shedding material at extraordinary rates, with gas and dust expelled into surrounding space. Over time, this shedding can reshape the star's internal structure and contribute to instability. If Betelgeuse is currently undergoing accelerated mass loss, it may be reaching a tipping point, one that signals it is edging closer to a supernova. The timing of this event is also fortuitous for the astrophysics community. The JWST, with its unprecedented ability to capture infrared light, is perfectly suited to study stars like Betelgeuse, which are often hidden behind layers of cosmic debris. The telescope's advanced instruments can dissect the components of the light emitted by the star, revealing intricate details about its temperature, structure, and chemical composition. With Betelgeuse as a prime subject, the JWST offers scientists a real-time laboratory to investigate the transformative stages of a dying star. Yet despite the surge of interest and speculation, it's important to temper expectations. The recent increase in brightness, while extraordinary, does not guarantee an imminent supernova. Red supergiants are inherently chaotic and can undergo dramatic changes without warning. Betelgeuse may simply be going through another phase in its long sequence of instabilities, albeit one of the most pronounced ever recorded. Still, the scale of this event cannot be understated. A 250% increase in brightness over such a short period is not a routine occurrence. Something profound is happening within Betelgeuse, and astronomers are racing to understand its cause. This episode serves as a stark reminder of the dynamic nature of stellar evolution. Stars like Betelgeuse are not static. They live turbulent lives, influenced by a host of internal and external forces. Understanding these forces is key to decoding the final chapters of massive stars and piecing together the cosmic puzzle of how stars are born, live, and ultimately die. Betelgeuse's sudden transformation also reinforces the idea that the universe is far from a quiet, predictable place. Instead, it is a realm of constant motion, where colossal energies shape and reshape celestial bodies in unpredictable ways. One of the most thrilling aspects of this development is the potential for further discovery. Betelgeuse is now under close watch from a host of instruments, both space-based like the JWST and terrestrial observatories. These facilities will continue to track its every move, providing a stream of fresh data that could help pinpoint the origin of its recent changes. Over the next months and years, scientists will monitor its brightness fluctuations, search for additional outbursts, and analyze the composition of any ejected material. The insights gleaned from this monitoring could revolutionize our understanding of not just Betelgeuse, but all red supergiants. As observations continue, the possibility remains, however slim, that we might witness a supernova within our lifetimes. Such an event would be one of the most extraordinary astronomical experiences humanity could hope to see. Betelgeuse, with its immense scale and volatile temperament, has long been seen as a ticking cosmic time bomb. Whether this recent brightening is merely a precursor to further instability or the first sign of an impending explosion, one thing is clear. The eyes of the universe are on this ancient, burning colossus, and it just might have a few more spectacular surprises in store. As Betelgeuse continues to captivate scientists and the public alike, the importance of long-term monitoring becomes even more apparent. The astronomical community has mobilized to keep a constant watch on the star, using a coordinated network of observatories around the world. These include the Hubble Space Telescope, the Very Large Telescope in Chile, and several radio observatories capable of detecting subtle changes in the star's output across the electromagnetic spectrum. The James Webb Space Telescope remains at the forefront of this effort, with its unparalleled infrared sensitivity offering insights into regions of the star that were previously obscured. With each new dataset, scientists hope to piece together a more complete picture of what is happening deep inside the core of this aging giant. One key aspect researchers are watching closely is the behavior of Betelgeuse's outer atmosphere, which can act as an early warning system for more dramatic changes to come. By measuring fluctuations in temperature, density, and chemical composition, astronomers can identify shock waves, pulsations, or mass ejections that could hint at a rapidly approaching end. These measurements can also help refine existing stellar models, many of which still struggle to accurately simulate the final stages of massive star evolution due to the sheer complexity involved. Furthermore, Betelgeuse is playing a pivotal role in bridging observational astronomy and theoretical astrophysics. Every shift in its behavior feeds directly into simulations and computer models that attempt to replicate how red supergiants function internally. The goal is to eventually predict with a higher degree of certainty when a star like Betelgeuse will go supernova. Current models suggest that once a star of this size exhausts the supply of lighter elements like hydrogen and helium in its core, it begins fusing heavier elements in increasingly shorter phases. Eventually, the fusion process reaches iron, a dead end where no more energy can be extracted. At that point, the core collapses under its own gravity, and the outer layers are expelled in a violent explosion. Whether Betelgeuse is nearing that iron threshold remains unknown, but the possibility is enough to drive intense research efforts globally. The broader implications of this event extend beyond just one star. Supernovae are not just cosmic fireworks. They are crucial to the chemical enrichment of galaxies. These explosions scatter elements like carbon, oxygen, and iron into space, seeding future generations of stars and planets. Understanding the timeline and conditions leading up to such events informs us not only about the death of stars, but also about the birth of new